Welcome to this class on Neuroscience of Human Movement. In this class, we will be discussing parietal and premotor cortex. Please note that unlike previous classes, the quantity of content in this topic and the depth of the discussions will be relatively limited, because this is not exactly a motor component, but rather more related to association component. So, this is the reason this is not at the end of the semester, at the end with some details presented, but not too much details. So, those who are interested in the topic can always consult the textbook and learn more on their own. So, in this class we will discuss the idea that voluntary movement is essentially a manifestation of an intention to act. This is something that we have been discussing in the previous classes. Essentially, any movement that you make is a manifestation, is the behavioral outcome of a decision that has been made or an intention, right. Note that this can be an internal decision or stimulus driven decision, or in other words, this can be in response to a stimulus, or this can be just spontaneous. For example, you are sitting and you just decide to have coffee, right. That could be considered as a spontaneous decision, or you are sitting, a friend comes along and then asks, hey, do you want to have coffee, right. That movement that you are making in response could be considered to be response to a stimulus. Information about the environment and the body is crucial to make voluntary movement. So, when you are making a movement, you need to know where you are moving, the property of the environment in which you are making the movement, and about your own body state, right. So, environment and body states are crucial to make specific and accurate movements, right. And also the object location is a crucial input to reach, right. So, if I have to reach to a particular point in space or pick up an object from a particular point in space, the location of that object is important. What is also important are the properties of that object, what are the affordances of that object, something that we will discuss in future classes, right. Let us suppose that this coffee is placed on a table right in front of you. Well, then in that case you just have to reach for the cup and pick it up and drink the coffee. But let us suppose that the coffee is not on the table and you still want to have the coffee. Well, in that case you have to make coffee, right. You make coffee and then you drink it. Suppose you go to the kitchen, look for coffee, so you can make it and drink it, and then you realize that there is no coffee. Then you need to go to the store and get the coffee, make the coffee and then drink it, right. So, this particular decision to have a coffee could have multiple consequences, right. So, depending on the context, depending on whether coffee is right in front of you or not, depending on whether coffee is available at home or not, right. Suppose you have to go to the store, then you have to make a movement to the store. That might involve movement with your own limbs or movement in a car, for example, right. So, essentially as we have seen previously, movements are made by muscles. The control is through spinal cord, and motor cortex sends commands to spinal motor neurons, right, through interneurons. Basal ganglia and cerebellum modulate the motor information that is sent to the spinal cord by communicating with the motor cortex. Note importantly that basal ganglia and cerebellum do not communicate with spinal cord, but rather communicate with the motor cortex, right. And association areas also provide crucial inputs to the motor cortex. This can be premotor cortex, supplementary areas, other prefrontal regions, right. So, these regions constitute movement planning areas, and the motor cortex and the spinal cord and the peripheral machinery constitute the movement execution machinery. Okay. So, this could be classified as a rough boundary between planning and execution. So, that means whenever there is an error in a movement that is made, say for example, you have to make a particular movement and there is an error, it could be because of planning mistakes or it could be because of execution mistakes, right. So, errors may be arising due to either of the two reasons, right. So, let us remember that the body is in dynamic interaction with the environment. This is a nice schematic prepared by my student, former student Satish, where he says that the body is interacting with the environment through multiple modalities. This might involve touch, audition, vision, and essentially the sensory systems, and the nervous system forms one component of the body, is it not? So, the nervous system is interacting with the rest of the body. So, for the nervous system to make its decisions concerning movements, it should know about that, it should know about the environment, it should also know about the body. So, essentially the human body in the environment is in a dynamic interaction, right, and through multiple modalities. Only some of these are presented here. Note, voluntary movements encode an intention to act, right. So, if we train monkeys to respond to specific cues, right. So, a target is lighted here for example, and then there is a go cue, right. So, there are two things, one is specifying where to go or the target location, the other is specifying when to make the movement, right. So, these two things are encoded apparently by different sets of neurons, right. So, the go cue for example is encoded by neurons that are believed to be probably more involved in the execution, and the target decision making that comes with perception of the target are encoded by neurons that are believed to be more involved in planning of the movement. So, if you have an instructed delay task in which first a target is presented and then the go cue is presented, what you see is that there are specific sets of neurons that are active when the target is presented and a different set of neurons that are active during the actual go cue is getting presented in the actual movement. Okay. So, this means that the voluntary movement essentially encodes an intention to act or is a manifestation of a decision making process. Okay. And also what has been shown is the idea that the dorsal visual stream, right, is the how pathway. So, it is not just about what and where is the object or what is the object, but also how particularly this is going to happen. Some nice examples from Mel Goodale's lab is presented here. So, there is this circle that are two sets of circles that are presented, and one circle, for example, this orange circle I am going to call this as C2 and this I am going to call as C1. C1 and C2 are essentially of the same size, but C2 appears larger than C1 perceptually. But when you provide this as cues in movement related tasks, it has been shown that these two things are not discriminated by the movement system, by the dorsal visual stream. So, essentially showing that this is an area that is involved in the encoding of how. Right. So, this is also called as the how path. This is a controversial notion, but still just wanted to present that idea. Right. So, also what is encoded is the specific region in which the object is located. Right. So, the idea that what is present in the parietal map is essentially a single map. What is also to be noted is the representation of space in the cortical area. It is believed, or it was believed some time ago, that the cortical areas host a single map of the extrapersonal space, of the space. Right. But now it has been shown that that is not true, that different sets of neurons respond depending on where the object is. For example, an object might be very close to your body or an object might be slightly away from your body, but still within reachable distance. For example, this pen, if it is kept here, and that is something that I can reach right now, right? Not. So, that is still within reachable distance, but there are chairs on that side at about 6-8 feet away from here, that is something that I cannot reach. It turns out that perception of these objects, those that lie very close to the body and those that lie within reachable distance of the body and those that are far away or not within the reachable distance of the body, are encoded by different sets of neurons. There is now substantial evidence to show that there are independent maps that encode these 3 different spaces. These spaces are also called as extrapersonal or far space, or peripersonal space, the space that I can reach, and space that is very close to me, personal space or near space, right, or the space that is closest to a body. So, in summary, voluntary movement essentially expresses an intention to act, or is a manifestation of a decision making process, right, or is the behavioral outcome of a decision process, right, and it requires sensory information. What kind of sensory information? Information about the environment. I need to know where I am, and I need to know where my body is or where my body parts are, right. So, information about environment and the body is needed, and reaching for an object requires sensory information about the object's location in space, where the object is, something that I need to know. So, with this we come to the end of this lecture. Thank you very much for your attention.